Alrighty. I think I should be able to do this with my phone. Yeah. Okay, cool. Awesome. So first of all, thanks for coming. This is going to be about as much AI as the last speaker and 100% less useful. It's automating waste loss with AI. This is basically just a toy project, a pet project of mine that I did a while ago. I also made a YouTube video about it if you're interested, but we'll go over how I made it, like some of the things that I found out, and hopefully it's interesting for you guys. So first things first, who am I? I'm Victor. I'm a developer advocate at a company called ClearML. ClearML is basically an open source toolbox for data scientists. So there's like an experiment manager in the toolbox, there's like remote execution in the toolbox, stuff like that. I have about 4 years of ML engineering. I was actually working at one of the biggest competitors of Redux, so thanks for getting me here. And I've also made YouTube videos, blog posts, contributions, things like that for ClearML in the open source space. I love tinkering and making with ML, as is why I make this a pet project. And then I'm also recently freelance at Project Y, so if you need someone, hit me up. I am available? Yes. Okay, but first, let's make something, right? This is about the pet project. How did I make it? And then what did I learn from it? So the problem statement was I'm working from home and I was not working out, like probably many of you were. It was Corona time back then. And so the conceptual solution there was to lock my PC every hour remotely. Don't let me log back in until I do 5 push-ups. That was the main premise of the pet project. And obviously, those push-ups would have to be recognized automatically, right? I can't just say that I did 5, because then I will always say that I did 5. And this is what I came up with. So this is the end result. You can see me doing the push-ups, and then you can actually see the computer unlock as well. The main idea here is that you have my screen with my computer. I have a Raspberry Pi in the corner of my room. It runs 2 models, right? One of which is actually running on an AI camera, which is called the Oak One. We'll go more into detail in a little second. I have one here. I'm actually going to do push-ups, so fun. That will actually output key points, which you will see in just a second. And then there is a second model that is actually running on the Raspberry Pi, not on the actual camera, that will go from those key points and then basically say, this is a push-up, this is a push-down, when I'm in like the down position. I'll go more into detail, but these are like, there's 2 models that we're going to be talking about. And then the Raspberry Pi can basically lock my computer from a distance. Now, what are kind of the challenges that I saw is one, locking the actual computer, which is harder than I thought. To get started, I'm running Linux, so that made things a little bit easier. If you're on Windows, you're basically screwed. So what I ended up doing on Windows instead of locking it is just spamming Notepad. And like Notepad would open like 1,000 times, and either I would have to click 1,000 times to close it, or do my push-ups and it would go automatically. But it's not perfect. On Linux, you can actually lock pretty easily. It's easy to lock your screen. It's very hard to unlock it remotely, which kind of makes sense, I would guess. There is no way to get a custom password either. So my first thought was, hey, why not just change my password to a random string and like save it and then type it again? That is a very bad idea. Don't do that. If your code is buggy, you will not get in anymore. So don't. And also, I know my own password, so I couldn't change it. But then if I lock my system remotely, that's all fine and dandy, but I know my password, so fuck the push-ups, I'll just type it in, right? So I needed to do something there. And the solution was to use, if you're using Linux, it's actually really interesting. There's like different kind of lock screens. i3 lock is one of them. And then the very high-tech thing that I use to not allow me to put in my password again is just to spam backspace. So that's actually something you can do. It's a tool called xdotool. It allows you to send remote keystrokes from a different machine. So it allows you basically, if you're SSHing into your machine, you can send just spam backspace 20 times a second. And there is no way you will get your password typed in that way. Because it just interlocks with all of your keystrokes, basically. So that actually saved it, because i3 lock allows you to send keystrokes while it's locked, right? That's what saved it. So xdotool, very good tool if you want to. This is a lot of code, and apparently I can't really see it from the back, or couldn't really see it back, so I'm sorry. Oh no. Okay, my laptop doesn't like being left alone for a while. But yeah, basically, looking at computer is actually relatively simple. So this is the class that is on my GitHub that you can go and check out. Basically, you get the SSH client, which is very simple. You lock the screen, and actually, this is a question I get all the time. What happens if you're in a meeting, right? Actually, in Linux, you can call puctl. I don't know what it's called. But it will basically say if your microphone has a lock on it, for example, by Meet or Teams or whatever, and if it has a lock on it, we won't lock the computer. So we can actually detect that you're in a meeting and don't lock it, because it would be pretty bad to see to have a customer see you do 5 on a call. That would be pretty bad. Then you basically just send the i3 lock command to the remote machine, and then you start spamming backspace, which is just sending an xdo tool command over SSH. Super simple. This is like the whole block, but it doesn't do very much. It just spams backspace. Yes?
What if you leave the meeting running all day?
The meeting running all day? Yeah. Then you game the system. It's true, yeah. But the fact is that most of the time you're kind of okay with working on yourself until it happens. But then you didn't think about it, and it's already locked. So you have to want it at least a little bit. Yeah. I also don't like meetings. I am very happy to say that I have a quarter of an hour of meetings every week now, which is really not a lot. Right, the second challenge is BlazePose. So now we're getting to the first model that I'll be running. It's actually using this thing. So that's the one here. You can check it out in just a minute. It's called the OpenCV AI kit, or the Oak 1. You have an Oak D as well for 2 stereo cameras in depth. It's really awesome. I got it on a Kickstarter for $150, and it basically has an Intel Myriad X chip, which is like an accelerator chip inside, but it's within the camera chip, like within the camera system on a chip. So it's really, really fast. As seen here, so if you have the Oak 1 plus a Raspberry Pi, you can get like 50 frames per second with an object detection network, whereas the NCS2, which is like the USB version of the same chip, has to basically pass, that basically means that the Raspberry Pi has to pass through all the imagery to the USB stick and back, which funnels it down to 8 frames per second, which is super bad. So the comparison is pretty obvious. The camera AI chip makes a lot more sense because the imagery doesn't leave the camera. And it also has excellent documentation. It has a lot of samples, so pose estimation was one of them, which is the one that I used. But you have like hand tracking, you have license plates detector. So it's really a cool thing that you can go check out. It's definitely worth it. So I used that system together with a pose estimation model. So basically this was almost out of the box, and you can just walk around. It will basically draw a skeleton on top of you, and then you can go along with that instead of the pixels, which is a lot less complex data. So the model that I used was BlazePose, as I said. So it's from Google's MediaPipe, which is a really cool library that you can use if you want to do AI on the edge, like with very fast models for embedded devices. And it actually had a port for BlazePose. So this means that there was already someone out there that ported BlazePose to this machine, to the AI chip that I could use, which was awesome. And it also actually does depth estimation. So it has a single camera, but it still gives a z-axis for each point in the skeleton. So you can actually see, it tries to detect, based on the image only, where you are in space. And also it has an online and offline pipeline, which is very important because you want to actually train the model. The second model that I'll be talking about in just a second, you want to train that based on the skeleton, which means that you want to be able to generate skeletons based on images that you already have, which is in the training phase. And then only later you want to do it online, which is where you actually do the inference and you just go do the push-ups. Right, I wanted to make it a little technical. Basically, the premise is BlazePose has a paper, but it's only 3 pages. So I figured let's go through it. So those are the 3 pages. How did they do it? It's actually really, really interesting how they made this thing so fast because it's still a very low-powered device and it can still do a lot of frames per second on these relatively heavy models. So they actually use a phase detector as a proxy for a person detector. So they say, okay, like in our use case, which is in their case was fitness, which is a perfect case for this. They basically said, okay, we want to do something fast, and detecting a person is not fast, so let's detect the face instead, and make the assumption that if you can see the face, that's the person. Like, that should be fine. So usually no one is going to be doing that to their model. That's just a very big assumption that they make. Sorry. And then I'll just do it from the computer, actually. And then they actually run this face detector only once every X seconds. And then in between, they have a second model, which is way faster, which will basically just take this face, find it in space, and then only track to the next frame, to the next frame. The assumption being that you don't actually have a lot of variation throughout different frames. You don't move that much over 1/10 of a second, which is 10 frames a second, or like 6 frames a second. Right, so to make it very fast-paced, as a consequence, a fast on-device face detector as a proxy for a person detector. That's kind of the assumption that they made. And then something really interesting that they did is not only did the face detector actually detect the actual face, it also detected a point in between the hips and a point all the way up top on the circle around the person. So it tries to find like the middle line of the spine, basically, of the person. And then the cool thing is that if the detector finds that, then it can give that to the tracker, and the tracker will, in every subsequent step, it will take the picture, and then it will try to reorient that spine straight, because then the model can always have people in the same orientation. And it makes it much, much easier for the model to find the key points, which is, I thought, was a really cool way to do it. And then this is what it says is based on either the detection stage of or the previous frame key points, we will align that person, like snap the spine to the middle, and we estimate the rotation as the line L between the mid and the upper head. So the scale is estimated based on all the body points in the square bounding box circumcised by the body. So then it basically knows this is the image where all the points should be in, and it can do it much, much faster. So that's kind of a nice thing. Definitely read the paper. It's only 3 pages, and it's really cool. Right, so if someone passes by, it actually has an additional class that it can do. So for every key point, it finds X, Y, Z, and then it also finds if it's occluded or not. And because they can actually do it, they had like a training regime where they just put in squares of like a fixed color in half of the frame, and then the model still had to say, this is where I think the hand is, based on the previous frames. And that allows you actually to just walk, like if someone were to walk in front of it, it would still have the tracked position from last frame. It will kind of remember where it should be, kind of like we do. Is like if someone walks past, you still have in your head like it should be there. They can't have moved that far. So that's kind of the idea here. But they actually did think about that. Right, then now we have this model, right? So now we have these key points for every position that I could be in. Now I want to actually train a second model that can tell me if this is a push up or a push down. These are kind of 2 classes that are interesting to us, and then we could go from there. So I had to label some extra images there. These are no models that are very easy to get because it's very specific, but also the skeleton isn't very complex, so we didn't need a lot of data, which is nice. But now it basically becomes a tabular problem. So if you take my picture and then take the skeleton, throw away all of the pixels, you're left with only the skeleton, which are just a few points. And then if you get that into a table, that's just tabular data, right? At this point, this is not very complex deep learning stuff anymore. This is just statistics at this point. So what I try to do is minimize the data complexity. So first of all, get rid of the Z. It's cool, but I don't really need it. You shouldn't need it to see if someone is doing a push-up or a push-down. Remove unnecessary key points. So for example, here you can see there's like a lot of key points for the different fingers and a lot of key points in the face for like the direction of gaze. You can throw all of those away. Just keep 1 point for the wrists, for example, just to minimize the data that the model should be working with. Yes?
If you remove the Z direction, that means that you have the push-ups only from a certain angle. So that
Yes. Yeah. It's true, and you will see that later in the demo as well. It's very fixed on my use case. That is definitely true. So if you want this in production, like for a lot of people, don't do what I did. But for me, it basically meant that I could minimize the amount of training data that I had to put in, and that was my objective. But this should still work. because the model, the Blaze pose model, is actually very robust. It's been trained very, very well, so it will always output key points very well, and throwing away the fingers won't very much change that. So it is still very robust to different people, because my model has only been trained on the skeleton. It doesn't care who is behind that skeleton, right? Basically, yes. But, I mean, I could borrow or like cheat or like steal the model from Google and then put my own on top and call it a day. And then also augmentation. So a lot of you probably know this, but you can do flip, scale, rotation to have like more training data. But also, this was fun, is jitter on the key points. And to keep it limited, you can actually have like a distribution. It's on my GitHub. You can actually have a distribution where sometimes you get like an extreme jitter and the key point shoots out, but it will rarely happen over all of the key points, which is like a cool class to do image augmentation. Right. So now, what are kind of the labels that we want to do? So now I threw away all of those finger joints, all of those like complex data. Now I have just a simple skeleton, and I want a label push up or push down. Right? These are just the two classes that my classifier should be able to classify. And then, well, how do I take a picture? Like, how do I get my training data when I'm actually doing a push-up, right? That's the next challenge. Like, I can't just press a button because then it will see that I'm always pressing a button. The answer is absolutely over-engineer it using an unnecessary amount of extra AI. So the main idea was that I had a camera. I actually made it voice-activated. And then I chained it together with like the voice activation of Google and basically said, if you detect the word label, just grab a picture. And then I could set it up beforehand to say, like, now I'm going to take a bunch of pictures of push up. And then I started, and then I just shout label, label, label. And it was a lot harder than I expected in the down position, but it worked. It worked. And in the end, I only needed like 20 pictures anyway, so it's not that big of a deal. I also do want to mention data version management. It's something that I usually forgot all the time when I'm working on a toy project, but it's actually really, really worth it. The main idea here is, so this is just what my flow was, right? You have the Oak One, which is taking the camera, taking the pictures. To my Raspberry Pi, I have a labeling tool, which is basically the voice-activated labeling tool, right? It will, every single time it's started up, it will grab the previous data set and will start a new version of it. And every single picture that has been taken is added to that dataset version. I use ClearML. Full disclosure, I work at ClearML. You saw it before. But basically, they have a data labeling tool, which allows me to keep track of these different images that I put in over time. And if I screw up for whatever reason, I can always go back to a previous version. I know every single time I train a model, I know on which dataset it was done. So actually, fast forward a few months, that was really, really useful. If you then have to go back and like see how everything worked, I was glad I did it in the end. So basically, you have a labeling tool. It creates a raw images data set. Then you can use preprocessing.py, which basically converts all of the images to the skeletons, right? And throws away the images where the skeleton was not found. And then you can create a new dataset version, which you can then pull in training. And then instead of, in your training.py, instead of saying, hey, take this CSV file, you can say, hey, take the dataset version with this hash. And then it just becomes much, much cleaner. So just a side note, check it out. It would be cool. Right, and then training my own model. And I also had to add some rules, obviously. Push up and push down is not enough. This is all it was. So in the end, it's literally just SVC from sklearn. It's not much more difficult than that. So in the end, it is 95% data analysis and then only this to actually train a model. To be fair, if you're going to my GitHub, you will find this, which is a little bit more. But in the end, you'll see it's all if-else statements for different kind of classifiers. I just used ClearML hyper-optimization, or hyper-parameter optimization to basically find the best combination of parameters for my my specific thing, but I had like 100% with the SVC. So yeah, it wasn't really necessary. I just wanted to do it. But yeah, that's what you get. Also, I did have to add some rules, but this is relatively simple. So in this graph, you'll see if the detection is 1, it is push down, I think. And if the direction is up, it is push up. So these are like the classes, right? So you can then see over time what I'm doing. And what I saw is when I walk to the camera, I have like a lot of push up, push down, and to not count that, I can basically say, okay, I will only prime it, I will only activate my counter when I have the push-up up position for like 20 frames. And then basically says I will not count anything until I know that you're in this position. It still doesn't work very well, but it works better. And then it starts counting there. And basically what you say is, hey, if the current detection is 0, which is basically I didn't find a person, you set primed to false, I'm not priming it. Then if the, yes?
Yeah, I don't understand why it counts when you walk, because your key points are not in the same.
Yeah, that is kind of the annoying thing about the classifier, is it's very simple, very little data. It's also very bad. Because also I didn't train it on data that wasn't me in the push-up up or push-up down position. So I never basically stood in front of the camera and said, label me. I should have done that. I'm a bit too lazy to do that. But that would have been a better option, because then you have a clause that basically says none of the two. I didn't do that, which is stupid, but yeah.
Why do not use the voice to start the application, the counting?
Because I will never have the motivation to start it on my own. So I need to be cut off from my work by locking the computer, that actually triggers it. Right, and then, yeah, basically you say, you count this edge, right? So you say, okay, it's super simple. If I have the push-up down position for a while, followed by the push-up up position for a while, that's one push-up. That's enough. It's, again, not super robust, but it's good enough for now. And then the last thing that I want to touch on before ending is just making a GUI. It's something I had to do anyway, might as well. Simple GUI is actually quite nice. I see that Gradio has been becoming the more awesome thing in computer vision, or like in deep learning in general. Simple GUI is actually quite nice as well. You have like the big libraries, Tkinter and like PyQt and stuff like that. Basically, this wraps around all of them, takes the one that you have, and just has like a unified API for it. And it makes it very, very easy to do. Also, it has a black theme, which is very necessary. But yeah, you can just basically apply a black theme, then apply the layout with like a column, which is the image, and then a column with 3 buttons. That's enough. Give it a window, and then you can just update stuff in your window, like the count number and everything, just as if it was a dict. So that's actually quite nice. It's super easy to get started. Why not? If you need just a simple program, it's easier than you might think. Right, this was actually all. So thank you for listening.